Hi everyone, in this short video I want to go over the matched molecular pairs analysis in Datagrok. So the matched molecular pairs will help you identify the key structural transformations and key fragments that drive the potency or different properties of the molecules such as activities, potency, solubility, and so on. So to launch the matched molecular pair analysis, you can open your molecular dataset, go to Chem top menu, analyze, and click on matched molecular pairs. Here, choose your desired activities that you want to target. In this case, it would be the cytochrome P and the hERG. Choose your molecular column, in this case it's SMILES, and the fragment cutoff, which will determine the ratio of fragments to cores that will be used to chop up molecules and compare different fragments. Now let's start the analysis. And in a matter of seconds, you will see a matched molecular pair analysis viewer that was added to the table. It has multiple tabs, and let's go over them one by one. So the first tab is the substitutions tab, where you would see all possible substitutions that occur in this data set. And you can see that the most common one is from methyl to ethyl or vice versa. You also see the average activity or property change that was associated with them. Since we chose these two, I'm going to be shown these two, and these are the average change of activities for the pairs of molecules that contain this sort of transformation. Now I can click on any of the rows here, and on the bottom side, on the pairs grid, I'm going to be shown a list of molecular pairs that have this sort of transformation. So for example, if you look at row 3 and click on row 3, I'm going to jump to the point in the grid where these rows are pinned on the top, and I can see that the methyl group from molecule 1 was substituted by ethyl group, and this was accompanied by 0.6 change in cytochrome P activity. The next tab is the fragments tab, where I'm going to be shown the similar sort of information but using a trellis plot visualization. So on the bottom side, on the x-axis, I have the from transformations and from fragments, and on the y-axis I have the to fragments. And you can see that on the right side here, you can also filter those out. So you can use different filters like substructure filters for each of the axes, or you can filter by the average change of different properties using the histogram sliders as you see here. And similarly, on the bottom side, I'm going to be shown the pairs of molecules that are involved in this substitution. So for example, if I click on the cell here, on the bottom side, I see one pair of molecules which have this sort of transformation. The next tab is the CLIFS tab, which is going to show basically a chemical space of molecules, apply some filters to it, and also show the arrows which correspond to different activity changes. So in this case, the yellow one will be for hERG, and the blue one is going to be for cytochrome P. I can zoom into any of these locations, for example here, and if I zoom enough, I will also see the circles that are corresponding to the molecules. I can hover over the lines, and I'm going to be shown in the tooltip the exact transformation that occurred between those two molecules with highlighted fragments, or I can click on the line and the more detailed view will be shown on the right side here. And the final tab is the generations tab, where we can use the information that we gathered throughout the transformation. So we looked at all possible transformations and fragments that occur in this data set, and we also got the information of what is the activity change associated with those transformations. So now we can apply those rules to try to generate new molecules that try to maximize a certain property. And here you can see that from the data set of 20,000 molecules, we have gathered over 40,000 different predictions. And here I can see the original structure, the core of the molecule, the fragments of from to. So what fragment was substituted by what was the generated molecule by resulting in this transformation, and what is the predicted activity of the given molecule. Now, as you can see, some of the generated molecules can already be in the data set. And this means that we can look at the predicted values versus the observed values, and we can plot a very nice scatter plots that you see on the right, and also fit a regression line to it. So in both cases, as you can see, there is a quite good regression line fit here. And basically, this information can be used to pinpoint the key transformations or key fragments that massively impact the activities or desired properties of certain molecules. This has been it. Thank you very much for watching, and see you in the next one.